Hi guys, my name is Shashi Menon. I'm the president of Menon Associates LLC, formerly known as Systech Technologies, and we are a modeling company developing software products for liquid and gas pipeline. So today I'm going to be discussing two main programs, one called LIQTHERM for liquid pipeline hydraulics, another one called GasMod for gas pipeline hydraulics. So we'll go ahead and show you a typical screen and model a typical pipeline, one for liquids, another one for gas pipeline. So now let's shift to our model screen, and right now we're showing a LIQTHERM pipeline opening screen, which shows you the help about screen, showing the name of the program LIQTHERM and the serial number and who is licensed to use the program. So we'll take a typical example. In this case, I'm going to be opening a 24-inch pipeline, which is called, let me see here, 24-inch Glatin to Lakewood 24-inch pipeline, and that is something like this. And the flow rate through the pipeline, initial flow rate is about, say, 300,000 barrels per day of diesel, and it's at 70 degrees. So let's save that information, then go to the pump stations, and we have 1, 2, 3, 4 pump stations, and the pumps are called Harvard_TBD, but what I'm going to do is just going to put a TBD, which means to be determined, and we go to the next station, and then also TBD. Then the next station is pump station number 3, and also TBD. So we had to put TBDs for each station, and then let the program calculate the required pump curves. So these are the stations, and we save it, and the next step is to go ahead and run the calculation. So let's calculate, but before we do that, we're going to have to save it. Go ahead and save the results, and then start calculating, and we come up with a screen where your case number is, say, 1001, and we'll append the case number to the results. So this is 1, 2, 3, 4 lines of data for the project title, and we're going to use pump curves. We're not going to use TBD, so I just use TBD curves, MAOP check, maximum allowable operating pressure, and we're going to determine the maximum flow rate as well. So based on this, we're going to append the 1001 serial number of the output. And let's try to calculate. We start off with the 300,000 barrels a day flow rate. It starts iterating through the calculation and trying to get the maximum flow rate. Comes out to be 724,649. We'll sit down and wait for a little while, and you should be able to get the result shortly. Okay, now we've got the result here, and we have the program says the maximum flow rate possible is 395,563 barrels per day, and we're going to go ahead and close that, and then go back and open the report again, and we'll see how the hydraulic gradient is going to be shown. And for that, I'm going to close this and go to the hydraulic gradient and plot the hydraulic gradient. And this is the typical hydraulic gradient that you see here. Shows you the 4 pump stations, but the flow rate coming into the pipeline is 395,563 barrels per day, and the same thing going out. Now this is based on no pump curves or TBD curves. So what we'll do is we'll repeat this calculation considering the pump curves. So go back and calculate or simulate the pipeline one more time, but this time use pump curves, and we'll append the data with the serial number or the case number and start calculating. And of course it's probably going to take the same amount of time, 2 or 3 minutes. So we're going to let it run, and then come back and splice it. Okay guys, let's take for example a metric pipeline. Okay, we're going to select a metric pipeline, metric pipe 002.001. It's a 100 kilometers long pipeline, and the pipe size is 400 millimeter diameter, and so on. So let's see the flow rate. We have basically coming out at the beginning of the pipeline, we have flow rate of 1000 meter cube per hour at 40 degree temperature, and the product is called ANS metric. So for example, if you push F3, it'll go immediately to database, and that's the product. So that's fine. We're going to say save it, and then we start look at the pump stations. We have 2 pump stations, San Jose and Rio Grande, and then at San Jose we're going to have a TBD pump, so we'll call it TBD, and to be determined. Then the next station is going to be called Rio Grande. We'll put another TBD pump and first simulate it based on these TBD pumps. So we go and start calculating, and there's your 4 lines of description data. Supposing the case number is 1002, for example, and we append the case number. Okay, we calculate the flow rate and start off with 1000 meter cube per hour. It goes up to 1249, and then it comes down to 1154, and pretty soon you're going to get a flow rate, maximum flow rate, and this is based on TBD pumps. You can see it 1154 meter cube per hour. Let's take a look at the hydraulic gradient, and it shows you a typical hydraulic gradient like that. Now it's again 1154 meter cube per hour. So let's close this and let's try and do it with the pump curves that it created. So you go to the pump stations, you can see San Jose and Rio Grande. Now you have a pump called San Jose underscore TBD. If you double click on it, it shows you what kind of a pump curve which is created internally. Then you go to the next station, and we go to Rio Grande. We got something like that. So all those are fine. We'll go ahead and run it this time using the actual curves. So we go ahead and run it, calculate, and it's still complaining. So we have to go to the pump stations and go to the stations, and at that point we're going to push F3, and it comes up with the San Jose pump, TBD pump, and the next station would be Rio Grande. At that point push F3, and Rio Grande is taken from there, and we save it, close it, and run it, calculate, and still cannot find it. So that's alright. Let's go ahead and run the calculation, and off we go. We are going to run it with this pump station, and it's called metric pipeline. So what we'll do is metric pipeline. That's the pump station, pump curves, and we're going to exit the program. We're going to exit it, and that's the end of that simulation. Okay guys, we've seen a typical simulation of a metric pipeline. We showed the hydraulic gradient, and the calculations are shown. So at the end here, we're able to model the pipeline for certain flow rate. Similar situation can be done for any kind of pipeline, any kind of pump station combination. Okay, that's a good example.